Hello everybody. This video is going to be a little bit different. So this is a presentation that I gave last month, so November 2019, at the MuleSoft Meetup in Toronto. And I kind of wanted to turn this into video for two reasons. First, of course, I wanted to share it with everyone else besides the 100 people that were there. And also, I wanted the people in the talk to actually pay attention to it because I had a few areas where I want to ask the audience, and I didn't want people having to spend their time taking notes or writing stuff down. So I wanted them to pay attention to be able to interact. So I did promise them that I would turn this into a video. However, it's not the typical video that I have because it's just slides. I'm just kind of, I'll see if I can get through it and see how it works out. So it's just going to be a slide presentation, but I will try to talk through and give some pauses so you guys can try to think about the questions I asked the people in the audience at the time. So this presentation is the biggest mistakes MuleSoft developers are making. Of course, this is all in my opinion. What I am, my name's Jason Estevan. I'm MuleSoft Architect and Developer at EsteSolutions. And EsteSolutions is my professional services company. For the last 5 years, I've been working in MuleSoft, but just for the last few, I've been on my own. So I now typically bounce around from company to company in Canada and the US, helping with just MuleSoft. It's mostly project-based, so it's usually typically only for a short period of time. And the company usually is implementing MuleSoft for the first time, or they have a new initiative and they need help. So basically what I'm trying to get at is I have been on a lot of different teams and I've worked with a lot of MuleSoft different developers. And I was trying to make this, the goal was 30 minutes. That was my time, my speaking allotted slot. However, so I kind of kept it to only 6. But of course I could come up with a lot more. But so this is my top 6 mistakes. The first one is logic inside Java code. So you used to see this all the time. This is what you would end up when Java developers were forced to write a MuleSoft application for the first time with no training and under tight deadlines. So it'd be like the typical flow you would see is just on the right here. So you'll just have your inbound source and right away you're jumping to a Java component. And the Java component would be just on the left here. You'll see things like accessing this line here, the invocation property, that's accessing a flow variable. And then you'll see while loops and then appending. So you're doing string building. And then you return the string, which would be modified the payload, which would turn into the payload, and then it would continue with the flow. So there would be typical MuleSoft equivalent components for these Java applications. So like for example, you can access a flow ref using Mule expression language or data weave. The while loop, yeah, it could be a for each because you're just iterating over a list of a collection, so order data. And then appending could easily be a data weave transformer. So for each one of these mistakes, I have a little section on the bottom that deals with the impact. So who does this affect, and how does it affect others if you were to make this mistake? So for this case, your impact is really to future developers. So MuleSoft is really trying to be what they call clicks, not code. And what that means is they're trying to get you to create your processes using drag and drops, adding a few lines here, and really eliminating the dependency on writing a lot of code. So if you're writing Java code that contains all your logic, you're really assuming that any future developer that's going to work on this project has a history in Java development. And nowadays, you definitely can't make that assumption. And what you're doing is you're short-circuiting a lot of helpful MuleSoft features. For example, like munits. So there's no way to add a verify in the middle of one of these lines. Same with business events. So business events is a component where you can store, you can make a notification that gets collected. And it's because it's a component. You can't drag a component in this middle of this Java code here. So there's no way to catch a business event in the middle of a state here. Logging and error handling. It technically can be done inside a Java class, but you have to write a lot of extra code and handle many things you wouldn't have to do if you extracted your logic from this Java class into the MuleSoft flow. So MuleSoft itself is written in Java, but it's a level of abstraction. So you could, if you want, technically rewrite all of MuleSoft features in Java, but it's going to take a lot longer, be more error prone, and less manageable in the future. So overall, you're just kind of leading to a lesser quality application. It's tougher to understand. It takes more knowledge to update. People can't make changes as easily because they got to figure out, oh, hey, what exactly is going on. And a lot of people might not have the Java background. So you could, and I've seen this, a lot of these applications that do this, they do achieve what they're set out to build, the business feature, but maintaining and additions and maintenance afterwards is definitely a headache and takes a lot longer. Very frustrating. So mistake number 2, too complex. So this might be just our engineering minds at work, but I've witnessed many cases where the code is just too complex for no reason. So these are 3 examples that I've actually seen in my work. So in the first one was every flow was connected with a VM connector. So instead of just doing a flow ref from one flow to the next, this person created VM connectors on each. But what they failed to realize is that what they were doing was including introducing some async processing strategy, as well as messages were getting queued up on the queue. So because they were non-persistent, if for some reason the server restarted, messages would get lost. In the second case, this is where the developer noticed that, hey, we have some string of components, like a flow, that's not dependent on writing on another one. So let's see if we can speed this up and do them concurrently. And in the third case, what happened is this was an auditing system. So they wanted certain business events to get sent to an auditing system, which would write the business event into a database. So the thinking here was, if this fails writing to the audit, the whole execution is going to fail. And this isn't really a crucial time. This isn't really a crucial event. So if there is a failure here, we want to continue with our flow. So they wrapped an async flow around these components. And I understand what they were trying to do in all these cases. Like the second one, they wanted to speed it up. The first one, they were trying to create, I guess, some reliability. Maybe they had multiple, they thought they could speed stuff up because if you had multiple workers, you could distribute load better. And the third one, like I said, they were just trying to make sure that any errors in this non-crucial part didn't affect the whole flow. But what ended up happening in all 3 of these cases is that after the application was deployed to production, they generated these really weird errors. Ones that didn't happen all the time, and it was making it very extremely difficult and time-consuming to debug. And it involved a deep understanding of the platform to figure it out. So like I was saying in the first case, what was happening is that there was this async between all these flows that they weren't taking into account for. The second one, what was happening is that there was an error in one of the flows, but the second path was still executing. So the state of the application and the data it was being written to wasn't always sync at the same time. And the third one, what ended up happening is that you had this logger and the transform message modifying the payload. So depend on the main execution flow. So for example, if you have a stream coming in, this was modifying the stream, because they wanted to output the payload. And depending on how many components the main flow executed, it was getting a different input type. So this would only fail if, say, the main flow got to two components finished, or two message processors finished by the time this executed. So it was a very tough to debug. So the impact to this is to customers, operation members, and developers. So it's to customers because these errors, of course, were affecting the output of the application. Operation members, because they're usually, if your team has one of them, they're usually the ones who are first trying to debug this issue. And because these are very complex issues that were coming up, almost all the time, developers had to step in and try to figure out what was going on. So I say without a deep understanding, and it really takes a senior level person to try to have to know what's the back end workings to figure out why these issues were coming up. And I wrote here that there's little or no benefit because really in all these cases, they're really trying to squeeze a very rare use case. Like they're trying to speed this gather. How much is it really going to speed up your application? But the trade-off is that you're increasing risk of failure. So a lot of times I just say, if you don't really truly understand what's happening behind the scenes and what possibly could come up, just create it simple and move on. Don't try to over-engineer the solution. Mistake number 3 I see is memory management. The number one question I get asked about MuleSoft is about handling large data. People tell me MuleSoft can't handle X number of records, or MuleSoft is too slow when processing so many records. However, whenever I do a deep dive, their issue always turns out to be the mismanagement of memory. So in this first issue, what first common memory issue is, you'll see here there's a set variable and a flow ref. And the flow ref is calling a Salesforce, but this could be any outbound message. So what's happening here is that whenever you're crossing a transport, as they like to say, you lose your payload because your input payload to the outbound message gets replaced with the payload coming back from the third-party service. So common what people do is that they save the payload into a variable, and then after they make the outbound call, they reload the payload. But the unintended consequence here is that this payload is now being saved in a variable which is stored in memory. So if this payload is large, say you have a record set that's quite large, or if it's like an image, that memory, you're taking a large chunk of the memory. And if this is a common in the flow that gets called quite often, that memory could add up quite quickly. So and in the second case that I see quite often is many places I've been to, they have a standard that say they want to log all inbound and outbound messages. And I understand what they're saying. Having that audit trail in your logs, it's great for debugging. It's great to understand if your system is really working correctly. But one of the unintended consequences is that if, say we have, in this case, we have an outbound request that returns back all patients. What happens is that by default comes back as a stream, which is really just, it's not the full payload, but it's a memory, just a buffer, like a smaller buffer of a section of the payload. And what this allows you to do is not load up the whole payload into memory. But if you do a printout to a logs of the payload, this is what we call consuming the payload. So what happens here is in order to write to this log, the whole payload, MuleSoft is forced to take that stream and write it, the whole payload, into memory. So if this call is to get patients and you're returning them all with no filter and you have a large patient set, all those records are being set into memory. So that's going to take a large chunk of the available memory you have. And if this is, say, a batch job where you're running this again and again, quite quickly you can use up a lot of memory just because you want to have this log message here. So in the presentation Toronto, this is where I asked the audience for the first time. So this was a question where I asked people to say what would be the impact of this memory, and we got a lot of good answers. And the biggest, and this is kind of a tough one because as developers, we kind of just focus on our code a little bit, but the impact of this memory management is to the business. So if we're handling large volumes, or we're doing an API that hits quite frequently, or a batch job, we need more computer resources for this application to run. And in order to get more computer resources, you need a bigger machine. And if you're deploying this on a Cloud Hub version, the machine and memory management is sold in what they call vCores. So 0.1 vCore, I think, comes with 500 megabytes of memory. And if your application can't run in that, you now need to purchase the higher up, so 0.2 vCores. And vCores are not cheap by MuleSoft, and it's an annual cost. So if this application runs for years and you couldn't get it to run on a 0.1 vCore, you had to go up to a 0.2. So you now doubled the cost for every year that this application runs. So mistake number 4, I believe we're on. So in 2006, Uber had a security breach that, and this was the Bloomberg headline, affected more than 20 million US users. But this was just the US users. Some sort of personal information on all 57 million Uber users around the world were stolen. This included the driver license numbers of all 600,000 drivers in the US. And besides that, it actually was a tarnish to the Uber name, and it lost the trust of both drivers and customers. The company ended up being fined $148 million by the FTC. Granted, most of that fine was because they didn't disclose the breach to the public fast enough. And what ended up happening is hackers, they gained access to an Amazon Web Service, which was owned by Uber, using credentials that were mistakenly left in a GitHub repository by an Uber engineer. And that is why we never check in unencrypted sensitive values. So MuleSoft allows us in our property files, they have a module, I think it's called like MuleSoft Security Vault or Security something. And it allows you to not print the sensitive information in your properties file, and it allows you to encode it, and then you check into your repository, your code repository, the checked in the encrypted value instead of the sensitive information. And I'd say even if you're planning on, say, I'll encrypt it later after I finish my code, I would recommend that you do it right from the start, because GitHub keeps page edits, histories, and they are accessible. So even you might say that, if someone sees my main branch, they'll see the encrypted password. But if they click on page histories and go back to the first one, if you checked in anything that was unencrypted, they'll be able to see that. And I would include this to cover test and pre-prod systems as well. Oftentimes, there's security information in these systems. I've seen many times where production data is copied into a test system to help with development. And a side note is that the AWS S3 data store bucket that got hacked had the credentials had full administrative privileges for all their data in S3. So when I say I'd recommend that if you're ever requesting accounts for access, only ask for the specific data set or functionality you need, so that if you do get a breach, they call it the blast radius, will be much smaller. Another fallout from this incident was that it led to the departure of the founder, Travis Kalanick, from the company he started and built. And all of this was because a single engineer didn't secure the properties. Don't be that engineer. Mistake number 5, minimal viable product. So this is my personal development process that I've crafted over the years. Whenever I'm tasked with creating an API or scheduled job, I always start my development first with creating a minimal viable product. It helps me answer 3 important questions quickly. The first one is access. Can I make successful connections to all the systems needed? So for databases, what I'll do is I'll use, if it's an Oracle database, I'll use a client such as MS Studio, and I'll try to see if I can make a connection to all the databases that I need. If it's an API, I'll use Postman, and if it's to recreate requests that I need, and if it's FTP, I'll use a FileZilla to make sure that I can access the directories locations that I need. So often getting access to a system can be a long process, from days to multiple weeks. So getting this request in early is important. Plus, it's so much easier to code with real connections and knowing what the request and response will look like instead of trying to mock them all and guess. And even though it's not critical for development right from the start, it is important to take some time early in the process and check if your deployed environments, so whether on-prem or Cloud Hub, has access as well. So there's this great MuleSoft program provided called Networks, Tools, Applications. And this can help, so you don't need to build a custom program to test your connectivity. The second one is data. So do I have all the data needed to fulfill the objective? So after I've analyzed if the system has all the data I need, this can very easily lead to having to go back to the business to figure out where the missing part is. So I've had many instances where I found out that to get system out of an information system, I need a search parameter or identifier that I didn't have. And the third one is escalations. So what problems are apparent that will need answers from others? So this is kind of the catch-all of everything else that could pop up out at you. Anything from finding out that a third-party system doesn't support real-time API calls, or realizing there's no documentation to understand the database data you're looking at. You want to get these issues escalated and answered quickly. Don't leave these too late to where it delays your project and you're finding blockers during the time when you are expected to deliver. It'll also help you, as if any answers result in major code changes, you won't have to rewrite all your code. And the impact to this is to the business and yourself. So anything that needs the help of others should be identified earlier so it doesn't affect the project timelines. So if you leave these things to the last minute and all of a sudden when you have 1 or 2 weeks left and you're finding out you don't have access, you end up having to escalate this, and then everyone is on panic mode, people having to work weekends to get what you needed because you left it to the last minute. And then there's a lot of pressure on you because now all these people are working to unblock you, and now you were blocked. You didn't have any work to do, so you lost some time, and now all of a sudden you got to make that up because the deadline usually doesn't change. So now at the very end, you're adding stress to yourself. You're potentially working weekends and evenings to try to get it cramped in a time because you had these unseen events late in the game. So you want to get these things early so it doesn't affect you right at the crunch time. And the last one, number 6, is coding to the user story. So I'm going to present 3 user stories. And I'm kind of assuming that everyone kind of knows what user story is. If not, it's kind of like an agile approach to how we structure the work as developers and across the team, our development work. So we create these little short stories that help find what we need done, and then these stories are really good for the business because they can move them around, they can find out what's order they need to be done. You can help do project timelines or forecasting for pricing based on how many stories you have, and you also can kind of size out the story about how big it is, and that helps people organize your work so you're not overwhelmed and getting too many big user stories in a short period of time. So all 3 of these user stories I'm going to present are what's called a trap. So we're going to try to talk through, and of course in the presentation it was a lot easier. We're going to try to find out what the trap is for all 3 of these user stories. and why you wouldn't want to code to the user story. So in the first one, I have insert the create order API on line 45 of the order HTTP request.xml file and add the following to the choice component expression, or, and then there's a condition. So essentially what you're doing is you're going to line 45. It tells you to, of this exact file, and add this extra condition to a choice component that should be there on line 45. So the question I have is, how long do we think that this task will take? And in the presentation, a lot of people, some people said an hour, some people say a half a day. And essentially kind of what people are saying is that it seems pretty simple. You just go to line 45, make the change, save, commit, and publish. But that is actually the trap. So if we just do that, we have no way to verify that the change that we did, that the change did what it was supposed to do. Do we even know what it's supposed to do? If this create order API is a project we didn't create in the first time, do we even know how to test that we didn't break anything else? If something does go wrong, people are going to look at us and ask, didn't you test this before you released it? If our answer is, I'm just doing what it said on the task, this does not reflect good on us. It shows others that we don't care about our work or take personal responsibility for our code we are pushing to production. So if you get this task described as this, don't just code to the user story. Go back to the person who wrote it and find out what use case they were trying to fix. So user story number 2. So create an API that will validate if a customer exists or not. The API should accept the customer ID, and if it exists, return back true, and if it not, return back an empty JSON response. So again, this one is a little bit different than the first one. So it tells us the whole API to create. So in this case, we have the input and output. It takes an customer ID and returns back true or an empty. So in this case, not like the first one, we're able to create tests to verify that it works. Also, there's no chance that's going to break any existing code because it's saying create a new API. So create an API. However, there's still a trap. Take a few minutes and try to see if you can figure out what the trap is. So it's very similar to the first one in that they're telling us how to code. So we will be responsible for maintaining this API going forward. So don't let someone else dictate your API standards. So maybe we have an existing API that could be repurposed, say a get customers API. If not, it's probably better to create that API and give it to them to use to instead. So there's more chance that a get customer API that returns back the customer as an object will get reused in the future. And that's not the only way that the story gets us to break standard REST principles. The story describes returning back a Boolean, which is against REST principles. These standards are set in order to promote easy understanding, interoperability, and reuse. If we were just to code to this user story, we'd be creating a one-off, point-to-point integration that is hard to maintain. So it's completely against the point of implementing MuleSoft and the API-led connectivity strategy. And the last user story is create a job that syncs inventory data from our DB to Salesforce. And they have 2 requirements. So the data needs to be synced every 6 hours. And the second requirement is provide a flat file for the Salesforce team with the inventory. So this story doesn't get us to break any REST or API-led connectivity. And it's the first of the 3 to describe the problem instead of just telling us how to solve it. So they're telling us they want to sync the inventory data from our DB. So take a few minutes. I'm not going to give you a few minutes. Take a few seconds and see if you can figure out what the trap is if you were to just to code to this user story. sorry, I got the picture in the way here. It's really just saying provide a flat file for the Salesforce team with the inventory. So the trap here is that is again telling us the solution. So as a developer and integrator, you need to add your knowledge to the expert and expertise to the conversation on how to solve the problem the best way. So go back to the creator of this story and ask, why did you choose every 6 hours? Is there a reason why we can't use real time? Have we looked into using OData so we don't duplicate data in 2 different systems? And why are we using flat files when Salesforce has an API? These are choices that will make a better solution that maybe the writer isn't technical enough to understand. This is when you need to not just code to the user story, but instead reach out and share the valuable knowledge you have. And then I have the impact, and this is when another time that where I asked the audience, and we got a lot of great answers, and they were all correct because this one affects a lot of people. So this one affects the business, customers, your team, and yourself. So delivering something that introduces breaks, creates legacy code, or is not what was needed is a step backwards and a costly mistake that would have been better not started. So if you create an API that breaks something, you're going to affect the business, you're going to affect your customers, you're going to have to redo the work. Your team, if you have an ops team, is going to be probably going to be the one who figures out about the break from the customers, and then you're going to have to come back and fix it. If you create an API that isn't well maintained or structured or can't be reused, what you're doing is you're creating yourself legacy code, and then all your developers coming forward will be like, oh, I need to maintain this one-off API. I can't really change it because it's already connected, and it just becomes a pain always having that single API, like in the case of number 2. And number 3, it affects the business. So if you're just creating low quality APIs or jobs, it's just bad all around. So if you're only syncing data every 6 hours, well, maybe that affects your business. I remember back in the day, if ever you did banking on a weekend, none of your balances would be updated till like Monday morning on your account. So that was, you could tell, it was a batch job. But now that you can see some of these newer banks and more modern ones, as soon as you do a deposit or a transfer, you automatically see it in your bank account, the updates. So you can tell now that they've switched to more real-time systems. And often, sometimes as developers, we kind of only deal with other developers, and we take for granted all the knowledge that we have. So maybe the business person that is creating these stories doesn't understand the consequences of creating a real-time versus a batch system. So that's why I say don't be afraid to speak up and just have a discussion about what is the problem we're trying to solve. And this actually triggered a really good conversation in Toronto where people talked about, well, these user stories, they're not how they're supposed to be written. And my response to that was, first of all, these are all real stories. Like I've actually seen these in my work. But she had a good point is that in Agile especially, they try to get you to write user stories using this template where it says like, so you're talking as someone. So it's like as a product owner, and then it tells you what you're trying to do. I want to have my data synced from our database into Salesforce, and then it tells you like a benefit so that our customers can can list online how many products we have left to buy. And what they're trying to do there is actually to get you to stop coding to the user story. Don't treat the user story as a technical design document, but just have it with enough information so that you can size the story, you can schedule it, you can find out what priority it is. So these user stories are meant more for the business. As I was kind of saying before, like you can People use them for how big they are. They use them for pricing, like capital cost expenditures, to see how much, if you have a vendor, how much it's going to take, how much work your team can do within a 2 weeks. They call it sprint period. So it's not meant for you to code to it. So whenever you see it, whenever you see a user story that's written where it's telling you to do, don't fall for it. Don't code the user story. Take that information, discuss with who wrote it, and figure out what they're trying to do. And together, using the expertise that you have, trust me, you have it, you can add value to it, come up with the best solution for the business, for customers, and for your team going forward. Because anything you write, even if someone tells you to write it poorly, it's your team's responsibility who now owns it going forward. In this slide here, I kind of summarize the impact levels, the impact from the 6 mistakes. So I chose these 6 because of their impact. And you can see from this chart that even within the 6, some have clearly bigger impacts than others. So there's too complex. So the first one, the logic inside your Java code, you're really just affecting other teams, your team of developers, because you're going to have to maintain this code going forward. And if you don't, and some of the features that you can't use, it's really developer features. Too complex. You are creating just rare errors, so it's not like the API is broken, but it's very painful for your team and developers to try to solve them. The memory management, you're just affecting cost. The security configurable properties. So this one, it's a low chance that you're actually going to get hacked, but the impact is massive to the business, and it could end your career. And this one is pretty easy to fix. Just don't check in unsecure properties. The minimal viable product. This one affects yourself and everyone around you. And as I was kind of saying, it's very stressful. If stuff starts coming up and if you notice you having really, at the end of every project, it's just chaos and it's always stressful, or at the end of every release, you feel like you do nothing for them. If you're saying you have 2-week sprints, you'll notice that if you find that the first week of the sprint is very easy, there's not much work to do, and then all of a sudden the second week of the sprint, it's always chaotic and hectic, and you're getting tired of that, maybe try to think about a minimal viable product might help flatten out that work stress. And in this one, it's very low impact to you. So you're going to have to figure out all these issues and connectivities first. But you're just rearranging your work tasks. So you're now just doing it first instead of afterwards as they come up. And the second one, the coding to the user story, this affects everyone. So this one is definitely the highest impact. As I gave an example before, if you build something that's not even used. So sadly, I've had this before where I created an API and I spent a lot of time making sure it did great. And then I checked on the customer, I delivered it, and I checked on the business a few months later. I was like, oh, how's this API doing? And they're like, oh, we didn't need it. It wasn't what we really wanted. And I was very frustrated because I spent a lot of time, took a lot of pride in building it. But if I had gone to them first and said, hey, what exactly is your problem you're trying to solve? I would have realized that the user story and the document that they wrote wasn't what they needed. And this one is a tough one. This is definitely the toughest one to solve. You really do need a mindset change to focus more on the impact of the choices you're making. So I've kind of trying to summarize what can we learn from this list. I of course couldn't write down every mistake I've seen, but overall there's a general principle we can implement. And I think it does have to do with a mindset shift. So I kind of wrote down, as engineers, we have a passion and skill for solving problems. When we are given a task, we often want to dive right into into code and see if we can figure it out, often rushed as we usually are given a tight deadline. When implementing our solution, our engineering mind tends to focus on optimization, performance, and whether the code looks pretty. So you'll notice none of my mistakes that I have listed have anything to do with complex data we've algorithms, synchronous versus asynchronous processing strategies, coding standards, using the latest or newest feature or connector. So even though those are important, those usually just impact the impact is limited to you and your team. So if you take a step back and instead make decisions based on the size, sorry, I know it's cut off here. I can't move it. So if you make more meaningful contributions to others, customers will get products and services that help them. Businesses can build those products and services more quickly. Let's see if I could just move that. Product services more quickly and make a profit. Developers can focus on solving new problems and feel enjoyment and pride knowing their work is helping others. So again, I want to leave you with just the task to take a look to see how you work on a day-to-day basis and see if you're focused on improving your code or are you focused on improving the impact that your code delivers. And this is the last slide that I usually put in all my presentations, where just that if you want to, of course, you're on the YouTube channel, but if you haven't already, please, got some value from this, please hit the thumbs up button and subscribe if you want more, to be notified if you want more technical MuleSoft tutorials. And the second one is just the link to my LinkedIn. So this is kind of my messaging platform. So this is how, if you have any questions, any comments, or you want to chat about anything, yeah, hit me up on LinkedIn. I'm pretty active on it. And that's it. And I hope you enjoyed this video and stay tuned for more like it. Thanks very much and have a great day.